Hello again. This is Gary, and this is a continuation of this 115 kV DC elementary breaker 3B62 closed circuit. On the first video, we talked about the tables for the switches to explain the different contact positions. Now we're going to continue with the logic. So as you can see here, we have a positive rail and a negative rail. The dash box means this is outside in the field. It gives you a clue there, breaker 3B62. If you're not inside the dash box, you're in the control house. But this is outside at the breaker, inside the dash box. This circuit, for the closed circuit, is fed from this breaker. It's a DC breaker. It also feeds this additional circuit, which is on the next drawing. That's the alarm circuit. As you notice, there's an under voltage relay here, 27, loss of DC. So if this path were to de-energize and these switches were closed, this relay would de-energize and send an alarm to let you know that you lost your close power. Motor loss of DC. So this is specifically for the motor. The motor runs off of DC. So if the motor loses DC, this undervoltage relay will alarm. You have a knife blade here, which now sends power to this 50 amp circuit breaker, which now feeds your positive and negative rail of the closed circuit. In your closed circuit, you basically have multiple paths here. We'll start with the first one. This is your 52 MCS close. This is your closed selector switch. If I say close with the breaker control switch, and my 43 maintenance or normal switches in maintenance, it will allow me to send power or water all the way down to the 52C closed coil and close my breaker. That's one way I can close a breaker. These contacts here, so just a refresher, 63 is a pressure switch. That means I have to have good gas pressure. This 52Y normally close is related to this coil. This is the B contact indicating that the breaker is open because we're trying to close it. And this is a mech switch. What is that? You can find that on the breaker drawing. It's the mechanical position of the mechanism, and it's basically a series of A and B contacts, and it's associated with the spring charge. So if your springs aren't charged and your system's not ready to close, it's not going to close. This switch will be in the open position and it won't close. So that's what this circuit's for. So we just looked at one path. With your switch in maintenance, you can close it as long as your springs are charged. If I put my switch in normal, I can close it remotely through this relay. This is test switch. That's the name of the test switch, 3B62. Those are the test fingers. And this is a contact from the relay. Okay? This drawing sheet 14, we can go there and look at the relay, but that's another video. So this relay sends a close. This contact closes. It's going to take this path through the, remember you place a selector switch in the normal, now you can close the breaker. Once you get to this point, it's the same path. As you can see, there's two paths to close this breaker. So I know right off the bat, for me to digest this drawing and fully understand what is the takeaway, you can close the breaker two ways. With the breaker control switch at the breaker or through this output. There is no other way here to close a breaker. This is just a coil monitor, okay? This is a coil monitor into a relay that says, hey, I got power, and as long as I got power into N307, that means I have power to the closed coil, because the power comes to closed coil, as we discussed in the beginning, comes from here. That's basically it. It's a pretty simple circuit. But the key takeaway is I can only close a breaker two ways. The local breaker control switch and this out 202. That also tells me that in the control house, there is no remote breaker control switch for me to close this breaker. I have to use the output of the relay to close the breaker. So that's just something that you need to know, because some point down the road, you're going to have to close and open this breaker. And if you're inside a control house and the breaker's 500 feet out in the yard, you're either going to have to walk out to the yard and close it, or you're going to have to get into the relay and pulse this output. All right, guys, girls, this is the closed circuit. Have a great day.